So, significant figures are the number of digits in a value that contributes to the degree of accuracy of that value. And that value can often be seen as a measurement. Non-zero digits are always significant. So let's have a look at some examples, because that's a very good way to get an understanding of this. So let's have a look at the number 9,100. If we're looking at how many significant digits are in this number, we just need to think about degrees of accuracy. So in this number, if we look at this as a measurement, let's say 9,100 meters, what we can say is that the zeros don't contribute to the degree of accuracy because they imply that this number could be rounded from another number, say, could be rounded from 9,104, and they've just rounded down, or, I don't know, 9083, etc. So this number has two significant digits, the 9 and the 1, because they contribute to the accuracy of the precise or the actual measurement, but the zeros don't. The zeros imply this could be rounded. So just here, 2SF, that's short for significant figures. Now let's look at 27. Well, given that I've said that non-zero digits are always significant, we have that this is just quite obviously correct 2SF as well. Let's have a look at another example. 0.023. You may look at this and think that, well, the 0 definitely contributes to the degree of accuracy because that's part of the number, the 2 does and the 3 does. It may appear that it's correct to 3 significant figures. But let's have a think about if this was written as 0.023 meters. This is equal to 2.3 centimeters. And looking at this number, you'd say that it's correct as 2 significant figures because obviously non-zero digits are always significant. And that suggests this here is correct as 2 significant figures as well. Let's have a look at example 4. Well, we definitely say that these 5 digits are significant because all non-zero digits are significant. So we have at least 5 significant digits. And I know that up till now we haven't been including zeros really. Every zero has sort of been ignored. Up here we ignored it, down here we ignored them. But there's something different about this 0. And what it is the fact that they've included this 0 in the measurement, let's say this is meters or something. The fact that they've included the 0 actually does add to the degree of accuracy because it tells us that this number isn't, I don't know, 4389.64 something. They've added this 0 to tell us that it is exactly rounded to this. So the value could be 4389.602 rounded down, but that O, it does contribute to the degree of accuracy. It's been somewhat vague so far, so let's have a look at 3 absolute rules for significant figures which we can always follow and we can apply to any case. So number 1, non-zero digits are always significant. That's one we've already known. Zeros between significant digits are significant. If you've got 305, the 0 there is significant. And number 3, final zeros are significant only in the decimal portion of the number. So let's have a look at a quick example that just illustrates all 3 of these points. Okay, so if we're asked how many significant digits are in here, well, non-zero digits are always significant. So we have at least those 3 are significant. Let's have a look at point number 2. Zeros between significant digits are significant. Well, we know that these are significant digits, so therefore these 2 must be 2 by rule number 2. And rule number 3, final zeros are significant only in decimals. Okay, well, let's have a think about what that means. Final zeros, so numbers that end in 0, are significant only in decimals. Well, it's definitely true that these zeros are in the decimal portion of the number. Therefore, these digits are significant too, for reasons that I explained up here as to why the final 0 in the decimal does add to the degree of accuracy. So in this example, we have 1, 2, 3, 4, 5, 6, 7. It's correct, 7 significant figures. So let's have a look at one last example. If we're asked, this is another way questions could be asked, write each number to 1 and 2 significant figures. Okay, well, let's look at part I first, part 1. 731,086. Well, to 1 significant figure, so we have to rewrite this number correct to only 1 significant figure. Therefore, we have to write a number that only has 1 significant figure. And given that this number doesn't start with a 0, the first digit of our number must be the significant digit. So in other words, we're rounding this number to the nearest 100,000. which would be 700,000. And if we were doing this to two significant figures, then, well, it would be to the nearest 10,000. So that's one significant figure, and that's to two significant figures. I'm sure you can start to see the pattern here. Part 2, 1084. Well, to one significant figure, that's just the first number, that's to the nearest 1,000. So we just get 1,000. And to two significant figures, well, that would just be to the nearest 100, because the second digit becomes relevant. And to the nearest 100, that is 1,100. Okay, part 3. 0.732. Well, again, to one significant figure. 0 is not significant, remember, because it's outside the decimal portion and it's not between two significant digits. And to two significant figures, we simply add the 3 as well. The last part, 1 and 2 significant figures. Well, we know that these zeros aren't significant because they're not trailing zeros. That's by rule number 3. So we write those down. And so to 1, this is the first digit we consider. Rounding here, it doesn't round to 0.01, it rounds to 0.02. And two significant figures is the exact same, 0.00, but now it's 1, 6, rounding the 5/8 up to a 6. Yeah, so that concludes this video on significant figures. Thanks for watching.